the prefixes here. Hopefully that will help you in your journey of naming, okay? Eat the test, okay? If I'm giving you names of things, then you can at least use it as comparison. So if your names look nothing like the form of these names, then you might have a problem, okay? You could also review your quizzes for these. That would help you out. So let's talk Ionic. Ionic is actually easier because you don't have to remember the prefixes, but harder because you have to take into account the charges on each of these things. So how do we do Ionic? Two names, I, and then, if necessary, you put the charge of the anion here. When is it necessary? Only if it's a transition or a post-transition metal, then you would put the charge there. Sir? Okay, so Na is sodium, I is, cut off the ending, IDE. Sir?
Do we add mono?
Nope. Non-ionic. Sir?
So why does iron have 3 if it's the first?
Because it is a transition metal.
Yeah, but
It could either be 2.
Wait, hold on. Sorry guys, I'm actually the teacher. I'm happy to answer the questions though. Iron has 3 because it's a transition metal. Transition metals are the ones that are in the middle,
Yeah, I see.
and so you have to specify what the charge is.
Where does the 3 come from?
Excellent question, which I will answer in a moment. Ryan, question?
Oh, never mind.
You got it?
I think so.
Okay, covalent. How do we figure out if it's covalent or ionic?
Yeah, that one.
Covalent is a nonmetal with a nonmetal.
Oh, yeah.
Ionic is a metal and a nonmetal. That's why you have that horrible question right there that says, identify the types, and is it ionic, covalent, or metallic? This was preparing us for our naming suffering now. Got it? So it all works together. Much like all things work no, that's a bad verse to quote the day before a test. All things work together for the good of those who love God, who are the called according to the purpose.
Why is it?
Because I'm supposed to be like this is miserable, and then you're like, oh, but it all works together for good. Smiley face.
No, if you don't study, it won't.
Yeah, true. What's
I feel
up?
like I'm gonna do
So,
that.
would a metalloid work for ionic?
A metalloid is a giant question mark. You don't know. Sometimes it's ionic. Sometimes it acts like a metal, and sometimes it acts like a non-metal.
Are we gonna have any questions using the?
Have I given you any guys?
I don't know. No, I don't think so.
No. It's pretty much impossible to figure out. So, that's that. I don't think I'm that mean. We also haven't covered it in class. Thanks, buddy. Haven't graded your math test yet, but no, that's good. That's good.
Still.
Okay. I graded yours, don't worry. You can say whatever you want. Okay. Calcium phosphide. What's the charge on calcium?
What? Like,
+2?
+2. It's in the second column. Have your periodic tables out. I'm going to come around. Maybe I should give a grade for this.
No.
Like, did you bring a periodic table to chemistry? Okay. Good.
you should memorize that.
I
The
have my
baseline.
regular one.
Periodic
That's your
table?
decked out one. I don't have my,
Yeah, actually,
I don't have my
You have
fancy period.
Yeah, I know where it is. I know exactly where it is.
Okay. Definitely going to give a grade for that in the future. That's going to be a thing.
So wait, Miss Blanda.
Maybe I should give extra credit. Okay, moving on. So,
1%. I'd be happy with 1%. Miss Blanda.
you can raise your hand.
Yeah.
It's all right. I'll acknowledge
We're
it.
still gonna have one of
One.
these at the end of.
Once you raise your hand, I'll acknowledge your question. Otherwise, we just all start shouting. Yes?
Oh, so you said we're not gonna have one on the end of the test. We have to bring our own.
Did I say that?
Well, no. Just one.
Okay. All right.
And in the weekly update.
That would be good. That's a good job. Okay. Of course, you will be provided with one. What's the charge on phosphorus?
+1.
-3. It is a non-metal, so we'll take a negative charge. So how do I get these to combine? Well, I would need 3 of these and 2 of those to equal out the charge. How did I get that? I just cross them.
Is that you always do that?
I don't say it always.
So
Do you do that a lot of
Generally,
the time?
you
Do
can,
that.
most of the time, yeah.
These are-
can you
Not
give
always.
an example? Do we have time?
Calcium is a-
All right, moving on.
Okay.
Potassium chloride. Potassium has a what charge?
No, calcium's a non-metal. No, calcium.
+1, thank you.
Wait.
Chlorine has a,
Minus.
Six, 7.
-1.
oh dear.
-5.
It's in the second to last column.
-1.
So find chlorine on your periodic table. You count back from the end.
-1.
The end is 0.
Oh, is that?
So it's -1.
Are you guys good?
Okay. The first column on the left, +1. The second column, +2. From the right side, the rightmost column is
3.
0. You go back 1, you get -1. Then you go back 2, you get -2. Then 3. Okay? So if you're counting from the right, you subtract. If you're counting from the left, you add. You've got this. You've got this. Okay? So these will come together and you get potassium chloride. Andrew, to answer your question, it doesn't work for polyatomic ions. Usually. Okay. Iron 3 oxide. So they give you the charge of iron, they give you the charge of oxygen. How do we get it? Cross them.
Done.
Done. Now, if you were given this to name, how would you know whether it's iron 2 or iron 3? This is how. You know the charge on oxygen is a
-2. 3.
-2, so the iron must be
3. 2.
+2, because 2 minus 2 is 0. So this is iron 2 oxide.
Wait, I don't.
You have to know the charge on things in order to name them ionically. I know. That's it.
Oh, you can just have it.
No.
Okay.
You guys doing okay?
I'm a little confused on that. Like, can you like?
You know the charge on oxygen.
Yeah.
So like a
got
month
that.
ago, I wrote like a list of like 10 rules for oxidation numbers. One of those 10 rules is that oxygen is always -2.
Yeah, I remember that.
Okay.
That's
Also on that list of rules, the first column is +1, the second column is +2, the last column is 0, and then you go backward. That's all your oxidation numbers. So if you're still lost on how I'm getting these pluses and minuses, review your notes. I think it's chapter like 8 or 7 on oxidation numbers. I think it's 7. Okay? So oxygen is -2. I need this to balance out to 0. In order to do that, I need this to be
+2.
+2.
So if let's just in fairy tale land, if oxygen was -3.
Oxygen is not negative.
I know, but in fairy tale land.
But in fairy tale land, if I have Fe2O3,
Yeah.
then I know I have 3 oxygens. So that gets me a -6. So my 2 irons must have a +6, which means iron is +3. Because 3 times 2 is 6. Horrible? Yeah, I'm aware. 10. So that is ionic bonding. Good question. That's what we just explained for the last 5 minutes. The Roman numerals are the charge on the first ion. So let's do mercury sulfide. Whoops, just gave away the name. That's horrible. But that's wrong anyways. So let's do the COS. That's actually mercury 2 sulfide. COS. So we don't know cobalt. We know the charge on sulfur. What's the charge on sulfur?
3.
It's in the second to last column. So it's either plus or minus.
-2.
Wait, I thought it doesn't matter with ionic too.
It does matter because you have to put the numbers.
But you're.
So I have this, right? Cobalt is a transition metal, so we have to put a charge on it. Okay? What charge are we going to put? Well, I'm going to work from my cation, my non-metal, to my metal. Sulfur has what charge?
-2.
-2. So cobalt must have a +2 in order to balance out. So this is cobalt 2 sulfide. So, why do we put the 2?
I know there's like 2, but doesn't that like cancel it out?
Right, but cobalt can have many different charges
Oh.
because it is a transition metal. So, because it's a transition metal or a post-transition metal, we must indicate the charge. Cool beans.
Is lithium a transition?
Is lithium in the first 2 columns? Yes. So it is an alkali metal.
Oh, okay.
Okay, so that's that. Polyatomic ions, you should memorize that list. You have your flashcards. I would encourage you to study those. Okay? 7 diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So if you're looking at a periodic table, it's like these guys. And that one. So if you're lost, just start naming off ones in this corner and you'll probably get it. Cool. All right, that's that. Talked about that. Talked about that. And that's a repeat. Cool. I will open it up to questions. I don't think I'm going to put chapter 9 on there. Should I be lazy? Yeah, I'm going to be lazy. It's the math one.
No. Oh my god.
We don't need for math. We don't need for math.
Wait, hold on. Sorry, this is not up for discussion. I am... Guys, it does...
That's
It's
Avogadro's
either-
number. Mole.
Oh, Avogadro's number.
You're trying to pass.
Is that the like the no?
Michael, we've already
is that
learned
the
all
like
about
Calm down. I'm not arguing
is
this.
that like 0, 1, wait, what's new?
Wait, hi guys. Teacher, teaching. 9A will be included because that's what I told you last week. So, that's that. Yes?
So what is gonna be new on the test?
9A.
9.
Cool. Questions? Yes.
Number 4.
Number 4. Thank you for asking. Okay, number 4 is to find. Is this going to work? Is this creepy?
The table.
Did it work?
The table's turn.
Okay, so these 2 columns represent the s orbitals. These 10 columns represent the d orbitals. Why? Because d holds 10. These 6 represent p, because p holds 6. These 14 represent the f orbital, because f holds 14. Okay? So, if I want aluminum, how do I get that? Well, I'm first going to fill the first row s orbital. 1s2. Then I'm going to fill the second row s orbital. How many electrons do I have for it? 2. Then I come over here. This is my 2p orbital. How many am I going to use? 6, because there are 6 spots. I'm on like a little road trip, right? You gotta go through this guy, I gotta go through this guy, I gotta go through these guys, through these guys, through these guys, and to this one to get to aluminum, right? So I have to include all of these. So I did 1s2, 2s2, 2p6, 3s2, 3p1. Now, I wanted the like noble gas one where you're lazy and don't write as much. So what would neon be? It would be 1s2, 2s2, 2p6. So neon replaces this part. And then we get our valence electrons.
Kind of confused.
Yep.
So like, how does that, you kind of like count that?
So I count. So the row is the first number.
Okay.
S is anything that's in here. D is anything in here. P is anything in here. And then the little numbers that go up there are how many of them I filled. So this would be 1s1, 1s2, because I filled 2 of them.
Okay, yeah.
Now I go here, this would be 2s1, 2s2. This would be 2p1, p2, p3, p4, p5, p6. That's how I got to neon.
Oh, okay.
Then 3s2, 3p1. Yeah,
So just like for the future, what if we use something in D and F?
well, what is D? We've already discussed it. It's one lower than the rest. So this is the 3D.
Yeah.
And then F is one lower than the rest of those. So this is 3D, 4D, 5D, 6D. This is 4F, 5F.
But if we use like kind of what's going on, how AL, P1, let's say we have to find manganese.
Yep. So that would be 3P6, 4S2, 3D, 5.
Oh, okay.
If that confuses you, you can always write out this table, which is not too difficult to write out.
That's what I.
And here's your favorite word. This always works.
That's what I did on the test. I did
Okay?
that one.
So, you know S will hold 2, P will hold 6, D will hold 10, F will hold 14. So, if you want to go through and find, since this is element 13, we need 13 electrons. 2, 4, 10, 13, 14. Whoa. 10, 11, 12, 13. So it's 1s2, 2s2, 2p6, 3s2, 3p1. Yeah.
How would that look like for like beryllium? Like, do you count?
Well, beryllium has 4, right?
Yeah.
So you would do 1s2, 2s2. There's only 4.
Oh, okay.
Yeah.
Doesn't that, it goes to 7 though, not 5S, right? So, like,
Yeah.
you just shortened it.
We would be here, much like the book of John, we would be here for hours and hours, countless hours, if I told you everything I knew about chemistry. Or maybe like 5 more minutes. You never know. You don't know how much I know about chemistry.
You wouldn't be a teacher for this podcast.
Maybe 10.
You're an engineer.
Yeah.
He's an engineer, he knows.
All right. So now the real part of that. So this was like We spent like weeks on that. How do I get the orbital notation? S has one spot, and you have 2 electrons to fill. P has 3 spots, so you have 1 electron to fill. That we spent very little time on. And then the last part, the 4 numbers come from this and that. The 4 numbers in order are 3. P would be 1. So if you landed in an s orbital, it would be 0. P is 1, D is 2, F is 3. M has to do with what spot you're in. So the middle spot's always 0. Spot to the right is 1. The spot to the left is -1. Spin, since it's going up, is positive 1/2. It was pointing down, it should be -1/2. So that is how you do the 4. We're now out of time.